Hello, students. Welcome to Chapter 8 in Psych 100 on memory. So to begin, let's take a minute to write in your notes what is something that you have a hard time remembering or wish you were better at remembering. So do take a couple minutes, write down two, maybe three things that you wish you could remember a little bit better, and we will probably be talking about some skills, techniques, or memory tricks to help with that. So pause the video and do that. All right, hopefully you've done that. As a reminder, a lot of what we're going to be talking about memory comes down to neurons and the brain structure, how neurons connect with each other. So hopefully you remember this brain structure and neuron function. So we've got the dendrites receiving a message, the axon sending a message, axon branches, which there can be a lot of, connecting with up to a couple thousand neurons on either side. So, how do our brains make memories? It's really through connections with those neurons. So, memory is just what we describe the process of encoding, storing information, and retrieving information over time. So encoding the piece there, you could think of this as recording the information. So you are writing a memory to your brain. You've got sensory inputs. Right now you're listening to a lecture, so you're getting that data. Encoding is writing that information, the definition of encoding into your memory. Storage is just the description of how we store things. Where is it stored? Where is the storage? And so you can think of the storage piece as like a hard drive on your computer. You're probably familiar with this term. And retrieval is then calling that back. So getting that information back out of storage. So if this was inside out, you would push a button on your console and pull up a little memory ball to show a little bit of a clip of what happened. So think of retrieval as opening a book or opening a file, if we're thinking of that storage idea of being a hard drive. So another big point of memory is attention. So if we're not paying attention to something, we're probably not going to remember it. We're not going to pull it into what's called our working memory. So attention is just simply focusing our mental resources. And so memory requires focus. A lot of our information processing requires focus. So as we pay attention to something, our cognitive processing of it improves. We're clearer about what things are going on, how to connect with things. So here is a little comic. Calvin in this example is definitely not paying attention. So obviously, Calvin is not going to remember the last 2 hours. It's not going to go into his memory because he wasn't paying attention at all. So with this, there are different ways that we talk about processing memories and processing the information that we're getting at any given point. We talk about it being shallow or intermediate or deep. So I'll try to give some examples to be a little more concrete with these kind of fuzzy ideas. So shallow is, let's say you're looking at this slide. You see some shapes and some letters. You recognize that they're words. That's very shallow processing. You're not reading the words. You just see, oh, there's words on this slide. There's words in that picture. There's shapes, there's letters, that kind of thing. I see a couple colors. That is a very shallow level of processing. That kind of processing is less likely to be able to go into your memory. Intermediate processing is a little more likely to go into your memory. Here, you'll give that stimulus a label. I see the color blue on the screen. I see the color pink on the screen. I recognize the couple words. I recognize the word label. I recognize the word recognize. So that is a intermediate level of processing of these words that we see on the screen right now of this slide. A deeper level of processing is thinking about the meaning of the word, how it's relevant. So as you look at the level of processing, thinking about, have I ever done shallow processing? Oh yeah, I can remember a time I did that. Have I ever done any deep processing? Well, doing this process of trying to think of examples is more deep processing. So a lot more attention being paid, a lot more cognitive energy being devoted to the task. So essentially what we mean by that is your cells, your neurons are using some more energy. They need to eat up more energy and to do their jobs. So that's really what we're talking about here. Another thing that influences memory is elaboration. This is an example of deep processing. It's forming connections around that new stimulus. So if it's something that you see that's new, some term in your book, whatever it might be, you might think of real world examples of the things we're talking about in class. So you might have just thought of, well, has there been a time I have done deep processing? That is an example of elaboration. So you are focusing your attention on this new stimuli. This might be, let's say, as you're driving down the street, you see something move. So you focus on it with intermediate attention and you see, oh, that's actually a dog right there. And then from there, you might say, oh, is the dog? Focus on a little more. Oh, that dog looks like my friend's dog. Oh, it's running out into the street. And what should I do about that? You are focusing more cognitive energy at that stimuli and hopefully are able to stop and make sure the dog doesn't get hit. So another big thing is imagery. Humans are generally really good at imagery. It really helps us to remember things. It's a powerful encoding tool from the time we're born. We have a lot of practice using visual stimuli and processing it. So it's a really useful tool to kind of leverage for making memories. So if we're having some of the neurons make memories through our visual processing center, that can help us remember it later on. And that is actually different imagery techniques are actually what these different world record holders for memory tasks use. So here's this first one as an example. This person memorized numbers in 1 minute with no errors. So they had 1 minute to look at a whole big list of numbers and then repeat that list of numbers with no errors. And their record is 102 numbers. So that is really astonishing. 1 minute to do that. We see random words in 15 minutes, recalling a single deck of playing cards. Oh my goodness, 21.19 seconds to memorize an entire deck of cards. So I probably wouldn't want to play any card games with that person. Um, but with that, these people are using imagery as a technique. It also might suggest, since they're all from Germany, maybe in their schools they are using and teaching more memory techniques, or perhaps there's a big or following for memory competitions, and so there's maybe groups that these people are joining and sharing techniques. But yeah, there's some pretty astonishing things we can do with our minds using imagery. Another example of this is that if you're trying to say learn a new phone number, you could use imagery by literally walking yourself around some numbers. So you can imagine them on the ground, you can imagine them as like big blocky numbers in front of you, and you like take a walk around them. That will help get those numbers into your brain. The first time you do that, it might seem pretty difficult. It might take more cognitive energy, but if that is a technique that you find works for you, as you do it more and more, it's going to be easier and easier and take less and less cognitive energy. So another example for using imagery for random numbers is you can make up a story and a visual image for each of these numbers. So maybe 3 is actually a guy with a big belly, and then he's got a cane. So the 1 kind of looks like a cane. The 4 kind of looks like a window, so he's looking at the window, and at the window he orders 15 hamburgers. So you have now turned this number into a picture in your head. So we'll talk about chunking in a minute. You've kind of chunked that number into an image that you can relate. You've associated it with other things. So imagery does work better in older children than younger children, basically because they've had more time to practice with their visual system and practice with their memory. So here are a couple brain areas really related to memory. So we'll focus a lot on the amygdala down here. We'll focus on the hippocampus as well. And then the visual cortex is back here. The cerebellum is involved, the prefrontal cortex, especially for working memory. So a lot of these are really relevant for memory. And any given memory is a lot of brain areas connected together. So your memory is not in just right here. This isn't where one memory is and another memory is over here and another memory is over here. No, your memory is in a bunch of places in a big network of neurons around your brain. So the hippocampus is, you could think of both the hippocampus and amygdala as kind of where the inside out characters live in your brain. The hippocampus has that direction of memory storage. So where should that memory be stored? Hey, neurons, make that into a memory. And then when you're trying to recall it, it helps you recall that memory. The amygdala is also here in the mid portion of the brain. If you remember, a lot of these middle structures have a lot of messages crossing back and forth. So the amygdala is very important for emotional responses. And so a lot of our memories go also through the amygdala. So as an example, you might remember the first person you ever dated. Maybe in the beginning, your memories of that person after you've gone on a couple dates are all really positive, really happy, but maybe later on you go through a really bad breakup. So now when you think of the memories of that person, maybe it's tinged with sadness or even anger, right? So that is now the amygdala has altered the memory just a little bit based on your new emotional state. So hippocampus and amygdala are very often part of memory networks. The olfactory bulb with smell, it's not actually pointed out here in this map, but it's about right here in the middle of the brain. So kind of like right behind your nose. And it is another one that's strongly tied to a lot of memories. You might have heard someone say, like, this place smells like my grandma's house, or something like that. A lot of smells are really tied to memory. Again, not necessarily every memory, though. The infert- inferotemporal cortex. Sorry, I'm recording this a little later than I usually do, so I can't say that word. So the IT cortex, this is why it's shortened to just IT cortex, is this area back here. So we're looking at visual functions, we're looking for patterns, shapes. It also touches into the somatosensory cortex. So we have a bunch of areas there, both with vision, shapes, as well as some senses. And then the somatosensory cortex itself is for feelings like touch, temperature, pain. So if you have a memory of a time you were playing with your cat and then your cat bit you, maybe you remember the softness of their fur and then also the sharpness of the bite, right? That might be that part of the memory would be in the somatosensory cortex. So the amygdala is really heavily involved in these memories. Gives us a good kind of cross section of half of the brain. So you can see the amygdala and hippocampus connected right there, prefrontal cortex right here. This is the olfactory bulb right there. And then the hippocampus really helps with direction of those memories. The cerebellum, all this outside wrinkly portion, also has a lot to do with remembering the language, like what was said, the visuals you were seeing, what were you hearing, what were your muscles doing. And then the prefrontal cortex is really important in specifically semantic tasks, things like goal setting and thinking ahead. So you can remember a plan that you have to do, for example. A lot of that's happening in the prefrontal cortex. So with this, any given memory looks kind of like this in the brain. So you see it's touching visual cortex, somatosensory cortex, prefrontal cortex, amygdala, hippocampus. This might be the network of any given memory, hitting at lots of neurons, lots of axons, connections through the brain. So maybe the hippocampus is over here talking to the amygdala, talking to the prefrontal cortex, talking to the olfactory bulb, talking to the IT cortex, talking to the cerebellum all over here, and then also the somatosensory cortex. So as you are having any given memory, you might be using all of these different areas of your brain. I just realized that I was pointing out the areas that it was connected to on the other screen. So just really quickly, hippocampus, amygdala, prefrontal cortex, olfactory bulbs back over here, IT cortex over here, cerebellum's this whole wrinkly portion, and then somatosensory cortex is about right here. But yeah, the point is the memory is all throughout your brain. Essentially, a memory is the most active neurons that were active during the event that happened. So it's usually about 5% of your neurons. What we've seen is that it's definitely less than 10%. We're still getting a clear picture of how many neurons become a memory, but it's probably in humans somewhere close to 4 or 5%, and that makes the memory. As you can see, this is a really great picture of axons mapped throughout the brain. So you can see the cerebellum here kind of separated from some of the other areas, but look how many axons are there. So many connections. So any given memory might be thousands and thousands of neurons activating in a specific pattern as a specific way to kind of help you, in a way, relive that kind of event. And that's what the memory is. So um, it's not quite what we see in Inside Out with just calling down a memory ball and playing a video clip. No, it's a lot more fluid and a little bit of flexibility with a bunch of neurons talking to each other. And like we said, they can shift and adjust just slightly as well, with, say, the amygdala being more positive or negatively valenced for that memory. So a big part of this is neurotransmitters. Neurotransmitters are, again, those chemicals that allow us to send a message across the synapse. And so there's a couple specific neurotransmitters that really help with creating memory. They do other things too. You'll recognize a bunch of these, but these are the main ones that are involved in memory creation. Epinephrine, dopamine, serotonin, glutamate, acetylcholine, all of these are heavily involved in memory formation and used in that process. So they might be used during the actual event, but also the hippocampus can kind of direct the neurons to refire. It often happens while you're asleep, but it also happens before that too, to rerun some of those programs or that network of neurons to reactivate them with some of these specific neurotransmitters so that those neurons become the memory for later on. So that kind of repeated neuron activity, so the pattern of all these neurons activating in the same place at the same time with these same triggers, that leads to stronger and stronger connections between the neurons. It means the next neuron in line takes less of a message to continue to activate. And that's essentially how we get a memory. These neurons talking to each other, making stronger connections, making it easy to trigger that memory and have that run as kind of a network of neurons programmed for a memory. All right, so here we see the neuron again. We've got those dendrites receiving a message, axon and axon branches sending the message. And so memories can be composed of thousands of neurons. So single neurons do play roles, as we see in the visual system specifically is one place that we've looked a lot at memories. We can see that some individual neuron cells can play a role in kind of calling back the memory of specific features, whether it's a shape, a person's hair color, these kinds of things. So as you get two neurons making connections at the same time, it leads to stronger connections. It leads to them needing less energy to activate later on. So again, less cognitive energy for that memory. So if you're remembering something really frequently, it's going to be really easy to remember it. As you're studying for a test, and then you go and do the test, hopefully you've made some more strong connections. It's easy to remember those things, but if you try to remember that maybe 2 weeks later, it might be a little harder. Maybe those connections have weakened by that time. So the brain remembers by recreating and kind of reactivating the neural pathways that you used in that original event. So with this, if you're still a little confused, feel free to send me some questions. There were some videos we skipped over here and some other videos linked later in the lecture that might help as well. But let's do some practice. I would actually like you to try to, even if you're in an online class or a hybrid class and are watching this lecture and not doing this in person, I would like you to attempt this activity. Before this activity, let's learn about some mnemonics. This is a pretty simple one, but mnemonics are basically just strategies to make connections and remember things easier. So for this one, you are using your knuckles to remember the days in the month. You might also be familiar with another mnemonic. You might have a little rhyme or song to remember how many days are in each month. So both of these are strategies to try and remember which months have 31 days, which have 30 days, and then which one has the 28 days. So it's a useful tool to be able to remember things. And that's essentially what mnemonics are, is a memory trick to help you remember things. So one really flexible to be used in a lot of different areas mnemonic is called the method of loci. So I've also heard it pronounced method of Loki, method of loci. It's also called the journey method. You might have also heard it referred to as the mind palace. So if you ever watched the recent Sherlock Holmes show with Benedict Cumberbatch, he talks about his mind palace, and that's literally what this is. So it's a mnemonic where essentially you imagine someplace that you know really well. So for me, I use the house I lived in high school. Just for some reason, I remember that one really well. You think of someplace you know really well, and then you connect things, new information, with things in that place. So your brain already has easy networks in it to remember this place, and then you connect the new information to that network. It makes it so it's easy to remember new things. It's lasting because you're connecting it with already existing memory networks. So as an example, I'll show you how you might do this with a list of random words. Maybe this is like your shopping list, but you can also use this for things like phone numbers or facts. As a quick example, if you're trying to remember a specific phone number, one useful thing is to chunk the numbers together. Oftentimes we do this just by default. We chunk the whole 10 number phone number into the first three numbers, second three numbers, and the last four numbers. So that is chunking it into three segments. So it's easier for our brain to handle those chunks of information versus all 10 numbers in the order. So we kind of remember the chunk of three, the chunk of three, the chunk of four. So if you use this method of loci with that chunking, you might imagine yourself walking through this front door, and here you see a clock, but rather than having a normal number on it, maybe it has the first three numbers of a phone number. Then as you continue to walk, you see a painting on the wall with the next three numbers of the phone number. And then maybe you look at the TV, and the TV, I think this is a TV right here. Um, and you look at that and you see the last four numbers of the phone number. So you have now connected these numbers with someplace that you already remember really well. So to give you an example, here are some example words. Again, I'm imagining the house I lived in high school. So I'm coming off the bus and I'm walking up to the door and I see a bottle on the ground outside the front door. In my mind, it's a Mountain Dew bottle because I definitely drank way too much Mountain Dew. That was before I ever learned about coffee and drank coffee. So I drank a bunch of Mountain Dew. So it's a bottle of Mountain Dew outside the door. I open the door and there's a cup. So pretty easy to connect that. You can even make a story with that. And maybe I start drinking the Mountain Dew in that cup. As I walk into the house and close the door behind me, I see the living room and a coffee table. There on the table, I see a bunch of paper. Maybe it's one paper, maybe it's a whole stack of paper. But again, I'm making connections with the bottle, cup, and paper in this location that I already know really well. As I walk through the house, I'm going past the back door and there's sand on the floor. Maybe a sibling like tracked in sand, right? I go into the kitchen, there's a box on the counter. Next to the box, there's a fork because it's a kitchen. There's probably forks there. So that is how you use this method. You try to imagine the place and connect these new words or the new numbers, the new facts that you've learned with something in that location. So make it meaningful to you, make it relevant to you. You can add stories. You can use also repetition or chunking in different ways. So the bottle and cup could be together if that makes more sense to you. Or sandpaper. It could be sandpaper to remember the two different things, right? So that could help. So with this, think right now, before I pull up the slide of the actual words, think about a place that you know really well. So what's your location? Is it a park? So like a big location where you can move and walk around? Is it a smaller location like a room, maybe your bedroom? Is it a whole house? So oftentimes people use like a whole building or something like that they know really well. So a house is a building that you might know really well. You could use your apartment floor plan. So spend some time thinking about where's the location that you know really well that you could imagine yourself like walking through. So hopefully you've got that. If not, pause the video and figure out a place that you know pretty well. Next, I'm going to bring up a slide for a minute and a half with a bunch of random words on it. I'll have a timer going. So as I bring up these random words, use this method of loci to try and remember all of these words in their correct order in only a minute and a half. All right, let me get my timer ready. So a minute and a half. I'll put these up on the screen and start now. All right, you've got about 30 seconds left. Great. So that is the minute and a half. Now pause the video here on a note page. Write down as many of those words that you can in the correct order. So do that now. Write down all of them that you can remember. Great. Hopefully you did pause the video and write those down. So with that, usually what we see in my various classes is that most students remember somewhere around 7 in the correct order. There will be a couple students who get all 12 of these. So here are the correct answers. There will be a few students who get all 12. Most will be somewhere around the middle, and there will be a few students who get maybe 2 or 3. So it's kind of a normal distribution, with a few getting just 1, 2, or 3, a few getting 10, 11, 12, and then most getting somewhere between like 5 and 8 in the as that they remember. So really good job. Hopefully you can see the utility of that kind of mnemonic, but there are a lot of other mnemonics as well. And essentially a mnemonic is just a strategy to make these kinds of connections in your brain. So think about how else you could use this mnemonic. I already mentioned a shopping list or phone numbers, but there's lots of other ways you could remember new things. You could organize a plan for a story using this method of loci. You could try to remember facts about something that you're learning with this method. If you want to learn some other mnemonics, this Wikipedia article on mnemonics has a list of a bunch of categories of mnemonics and a couple links to go through to find more information about a variety of mnemonics. And so I recommend you try things. Not everyone is going to have the method of loci work for them, right? It's good for a lot of people, but not for everybody. Everybody's brain works a little bit different. So yours might not like the method of loci. You might need another one. There are mnemonics designed specifically to help remember faces. There are mnemonics specifically for remembering names. There are mnemonics for how to do math problems. So try out some of these that you think might be useful. So with this, hopefully you can see how these processes of making memories, making connections are very similar to some other concepts that we've talked about when we talk about positive reinforcement and learning processes. You are making associations, you are making connections between your neurons for a reinforcement or for two things happening at the same time. A taste aversion is very similar neurologically to a memory. So let's talk about some different definitions of types of memory and the storage and things like this. I've alluded to a few things like short-term or working memory or long-term memory. So let's talk about that. So sensory memory is a really interesting and unique one. So it's information about that are coming from your senses, but it only lasts a little bit of time. So some of your senses are microseconds. Some of your sensory organs, like your rods and cones in your eye, are almost up to a second to a few seconds. So that is why it's possible to do something like this with sparklers, right? The light from the sparkler is actually only in one place at any given space and time. But if you're moving it fast enough, you can make this circle, right? And you, as a human, can perceive it that way. Some animals don't perceive the circle. They see it just moving around. But your sensory memory, is holding on to the light being right here, and right here, and right here, and right here, and right here, enough so that you can actually see that circle, which is pretty neat. I would try it with my mouse right here. Maybe I will. So here, and I'm not sure how well the screen recording will pick this up, but it's definitely not a complete circle as I'm spinning around my mouse on the screen just above this picture. So I'll have to double check how that looks in the actual recording. Maybe it doesn't look like anything, but it's pretty close. There's some gaps on my actual screen. It's like a centimeter between each of the um, each of the mouse arrows that I see. But yeah, that is a sensory memory, and it's very quick. And then if we don't hold on to it, if we don't pay attention to it, it will just be gone. It'll be out of your brain. It's just not there anymore. So as an example of this, you are always getting sensory data from all over your body, but if you're not paying attention to it, it won't enter your conscious memory, like your working memory. So right now, you probably have like a shirt with sleeves on your arms or your shoulders. And until I said this, you probably didn't feel that fabric on your arms or shoulders. But now that I've mentioned it, you might notice that it feels heavy or light or cold or itchy or smooth. So before I said it, those senses, those neurons were sending that message to your brain. But because you weren't attending to it, you weren't using anything, it was just really quickly just out of your brain. So it's another thing with our senses as well. All right, short-term memory is essentially what we talk about with things that we are not working with, but are there to be worked with for about 20 to 30 seconds. So as an example, for a 2-year-old, you can give them a series of digits to remember. And at 2 years old, they'll probably be able to hang on to two of those without doing anything with them, like without trying to rehearse them, without trying to repeat them, without thinking about what they mean or connecting it to their age or something like that. A 7-year-old is getting better at this and is going to remember about 5 digits. And then we see gains a little slower after that into the teens and into adulthood as well. But that is short-term memory. It's the things that are coming in. You can think of short-term memory as kind of a stream of constant information. So if you are not actually grabbing onto a piece of wood or floating leaf in that stream, then it just leaves outside of your vision in that 20, 30-second span of time. But if you reach out and grab it, now you can work with it. You can do a craft with this leaf that you just pulled out of the river, that kind of thing. So that is short-term memory. It's very passive. It's just what our brain is able to hang on to and kind of buffer for that little span of time. So we also do have a limitation here that we can only kind of hold 7 plus or minus 2 spaces of information. We can do things like chunking. Like here we've got Dory looking at shelves now. So there's maybe about 7 shelves here. So you can put things on those shelves, maybe a phone number, maybe a person's name, but we can't put everything that's going through that river of conscious inputs into short-term memory at any given time. So some of it eventually will just disappear. So then maybe new things are coming in and they might just disappear. So with this, if we start paying attention to something that is in our short-term memory, we've basically started working with it, and now it is called a working memory. So our working memory is what we most often talk about. Your working memory is your mental workbench. It is where you are making decisions. It is where you are manipulating info. You're trying to consciously remember something. So it's kind of like you're living in your working memory. Your consciousness is kind of part of your working memory. And so your prefrontal cortex is really heavily involved in this process because you have to think back, you have to think ahead, you have to interpret what's going on around you. And so this improves, your working memory improves throughout adolescence and into adulthood. It stays pretty consistent across adulthood. And then we do see some slow declines in late adulthood, so like 60s to 70s, and then steeper declines after about 75. But let's watch this video about working memory. It's a really good one that also asks you to do some different tasks at the beginning of it. So let's actually try to do some of those tasks as they are talking about it.
So yesterday, I was out on the street in front of this building, and I was walking down the sidewalk, and I had company, several of us, and we were all abiding by the rules of walking down sidewalks. Okay, we're not talking to each other, we're facing forward, we're moving. When the person in front of me slows down, and so I'm watching him, and he slows down, and finally he stops. Well, that wasn't fast enough for me. So I put on my turn signal, and I walked around him. And as I walked, I looked to see what he was doing, and he was doing this. He was texting, and he couldn't text and walk at the same time. Now, we could approach this from a working memory perspective or from a multitasking perspective. We're going to do working memory today. Now, working memory is that part of our consciousness that we are aware of at any given time of day. You're doing it right now. It's not something we can turn off. If you turn it off, that's called a coma. Okay? So right now, you're doing just fine. Now, working memory has four basic components. It allows us to store some immediate experiences and a little bit of knowledge. It allows us to reach back into our long-term memory and pull some of that in as we need it. Mixes it, processes it, in light of whatever our current goal is. Now, the current goal isn't something like I want to be president or the best surfer in the world. It's more mundane. I'd like that cookie. Or I need to figure out how to get into my hotel room. Okay? Now, working memory capacity is our ability to leverage that. Our ability to take what we know and what we can hang on to and leverage it in ways that allow us to satisfy our current goal. Okay? Now, working memory capacity has a fairly long history, and it's associated with a lot of positive effects. People with high working memory capacity tend to be good storytellers. They tend to solve and do well on standardized tests, however important that is. Okay? They're able to have high levels of writing ability. They're also able to reason at high levels. So what we're going to do here is play a little bit with some of that.
So one thing I want you to consider as we are watching in this video, and we will do this kind of exercise, I do want you to just follow along, try to do the things that he asks you to do during the video, but think about, well, why would you be better at storytelling or writing with more working memory capacity? If you were able to work with your working memory faster, why would that lead to those different things? So maybe put some of those answers in your notes. Why do you think you would do better at writing or storytelling if you had better working memory? And once you've done that, come back and we will watch this and follow along with this little activity he will have us do.
I'm going to ask you to perform a couple tasks, and we're going to take your working memory out for a ride. You up for that? Yeah. Okay. I'm going to give you 5 words, and I just want you to hang on to them. Don't write them down. Just hang on to them. 5 words. While you're hanging on to them, I'm going to ask you to answer 3 questions. I want to see what happens with those words. So here's the words. Tree, highway, mirror, Saturn, and electrode. So far, so good? Okay. What I want you to do is I want you to tell me what the answer is to 23 times 8. Just shout it out. In fact, it's exactly. All right. I want you to take out your left hand, and I want you to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a neurological test, just in case you were wondering. All right. Now what I want you to do is to recite the last 5 letters of the English alphabet backwards.
Z, X, Y,
You should have started with Z. All right. All right. How many people here are still pretty sure you've got all 5 words? Okay. Typically.
So before he goes into what we see in that, and I can see the actual talking there on the screen already, but what I usually find in my classes is pretty much what he finds in these studies, is that about half, maybe a little more than half in the classes are able to get all 5 words. And so one thing that I like to students to do is write down what strategies did you use for memorizing them. So did it work? Did it not work? Did you use imagery? Did you use repetition? Did you make a story? Did you did you chunk these words together in some way? For this specific thing, I always use imagery. So I mentioned earlier that I like to use imagery, and I use it a lot. It tends to be good for a lot of people, not everyone. Again, any of these given memory tricks are not going to work for every single person. But when he says tree, I imagine a tree. It's like green. It's kind of the stereotypical tree you might expect a kid to draw. Then he says highway. Well, now the tree is next to a highway. Then he says mirror. Well, if I'm got a tree and a highway and a mirror. This is probably a mirror in a car. So I imagine now I'm sitting in a car, I've got my mirrors around me. And then he says Saturn. So I imagine, oh, well, I see Saturn outside the car. Since he said mirror, I actually see Saturn in, say, my rear view mirror. And then he says electrode. And I don't really know what an electrode looks like, but electrode sounds like electron. So now my imagery scene looks a lot like a synthwave album cover, and everything turns kind of like shades of purple and pink and blue. And now around Saturn, there's not just rings, but electrons spinning around it. So I've got a tree by a highway. I'm in a car driving and see in the mirror Saturn really big in the back with electrons spinning around it. Even though electrons are not actually an electrode, that's the connection I make. So yours might have been similar. Sometimes students do use imagery, sometimes they use repetition. Um, but one interesting thing is with these other tasks, he's trying to put more strain on your working memory. Your working memory, as he'll discuss, can only hold about four things at any given time. That can be chunks of information, but about four things. So with trying to hold 5 words and then trying to do more tasks, you really have to use strategies to remember all of these. All right, we'll watch a few more minutes of this.
All 5 words. Okay, typically we end up with about less than half, all right, which is normal. There'll be a range. Some people can hang on to 5, some can hang on to 10, some will be down in 2 or 3. What we know is this is really important to the way we function. Okay? And it's going to be really important here at TED because you're going to be exposed to so many different ideas. Now, the problem that we have is that life comes at us, and it comes at us very quickly. And what we need to do is to take that amorphous flow of experience and somehow extract meaning from it with a working memory that's about the size of a pea. Now, don't get me wrong, working memory is awesome. Okay? Working memory allows us to investigate our current experience as we move forward. It allows us to make sense of the world around us. Okay? But it does have certain limits. Now, working memory is great for allowing us to communicate. We can have a conversation, and I can build a narrative around that. So I know where we've been and where we're going and how to contribute to this conversation. Allows us to problem solve, critical think. We can be in the middle of a meeting, listen to somebody's presentation, evaluate it, decide whether or not we like it, ask follow-up questions. All of that occurs within working memory. It also allows us to go to the store and allows us to get milk and eggs and cheese when what we're really looking for is Red Bull and bacon. Okay? Got to make sure we're getting what we're looking for. Now, a central issue with working memory is that it's limited. It's limited in capacity, limited in duration, limited in focus. We tend to remember about 4 things. Okay, it used to be 7, but with functional MRIs, apparently it's 4. We were overachieving, all right? Now, we can remember those 4 things for about 10 to 20 seconds unless we do something with it, unless we process it, unless we apply it to something, unless we talk to somebody about it. When we think about working memory, we have to realize that this limited capacity has lots of different impacts on us. Have you ever walked from one room to another and then forgotten why you're there? Okay. You do know the solution to that, right? You go back to that original room. Okay? Right? Have you ever forgotten your keys? You ever forgotten your car? You ever forgotten your kids? Okay? Ever been involved in a conversation and you realize that the conversation to your left is actually more interesting? All right? So you're nodding and you're smiling, but you're really paying attention to this one over here until you hear that last word go up and you realize you've been asked a question. And you're really hoping the answer is no, because that's what you're about to say. Okay? All of that talks about working memory, what we can do and what we can't do. We need to realize that working memory has a limited capacity, and that working memory capacity itself is how we negotiate that. We negotiate that through strategies.
So the rest of the video is really great. I recommend watching it, but we will jump ahead and continue talking about working memory and talk about some specific strategies that are really useful for students specifically. So as we look at this other example here, we've got a couple adolescents having conversations. So let's say that they're having kind of the same experience. Maybe in both these cases, the adolescents are trying to flirt with someone. When thinking about our working memory and what we have the capacity for, we're kind of hanging on to a couple things at any given time. We need to use our attention to pay attention to things, process inputs. So when we see these two adolescents talking and maybe trying to flirt, they're trying to come up with something clever to say. They're trying to pay attention to body language. They're maybe trying to do, it looks like they might be in a lab class, so maybe they are trying to do some homework at the same time, or pretend at least that they're doing homework as they're talking and trying to think of ways to impress the other person. So when you have all those inputs, the working memory is really attuned to that situation. And it doesn't take too much cognitive energy to do each of those different tasks. If we compare that to this situation where the person is texting, all you have in this texting setting is the words on a screen. You don't get the tone of voice, you don't get the volume level, you don't get if they're being sarcastic or not sarcastic, you don't know if that spelling mistake was intentional and they're trying to act some way. And so it takes a lot more cognitive energy and a lot more resources for your working memory to have that text conversation than to just have a conversation in person. You might see this in something like Zoom as well, even though you can see another person oftentimes. It might be a little more limited to an actual in-person conversation. Now, that being said, for any given conversation, all you need might be text, or all you need might be Zoom or a phone call, right? But these are some of the things to consider about our working memory. If you're wanting to say, flirt and get a date, it might be easier in that kind of context to do that in person rather than through text, at least for your working memory. I'm not saying it'll necessarily be more or less successful either way. But for your working memory, it's going to take less resources to do that in person. The inputs that you're getting are going to be a lot easier than trying to guess what's going on for your working memory. So, like it said in the video, when we have good working memory ability, we tend to have good language ability. We also see working memory improve in people who learn more than one language as well. We see also, interestingly, math skills go up, problem solving in general, reasoning. So, working memory is a really useful skill for all humans. So, wherever your working memory is at now, if you work on it, so work on your working memory, it can improve over time. So with this, we've talked a lot about some short-term memory, some sensory memory, some working memory. Let's talk a little bit about long-term memory. Long-term memory, if we go back to that example of the inside out characters, actually, I guess so. We've got working memory. That's essentially where the inside out characters are doing their work, the mental workbench of that table that they're getting their inputs, they're making their decisions, trying to decide what to do, calling up long-term memories. That is the working memory or the inside out characters. So if we go to long-term memory, this is relatively permanent storage. It can fade over time, especially if you're not actually recalling those memories. It seems to have a very large capacity. It doesn't seem like we've ever reached a human limit to long-term memory capacity. But again, that is a pretty difficult thing to test. You can't like just shove memories into a person's brain and see at what point is it going to stop remembering things. So with this, we do see increases in long-term memory happening through middle and late childhood. It's also growing in adolescence as well. But a lot of this is down to just figuring out how the brain wires itself up. So as you grow and develop, it's wiring itself up to be able to create long-term memories. It works with the working memory and with things like the hippocampus to figure out where should I put this memory. So where should I put this memory of this conversation that I'm having with the person I'm flirting with? Where should I put this memory of the learning to ride a bike? So the central executive is a lot of that's in your prefrontal cortex. It's you kind of planning, goal setting, um, determining what's going on. So a lot of that is working memory. Your visual spatial sketchpad is basically what we call the areas of your brain that are looking at visual information, looking for patterns, looking at colors, looking for things. And so a lot of that's happening in the back area of your brain. The phonological loop is where we're kind of processing sounds and spoken language as well. And then episodic buffer is kind of like what is happening in this episode of my life right now. All of those together are kind of how we describe how the working memory works to then put things into long-term memory. So there are a couple different kinds of long-term memory. One that I just alluded to a minute ago is an implicit memory. This is a memory that you don't have any kind of conscious recollection for, but if you've learned how to ride a bike, you could get onto a bike and probably just ride it down the street. You don't have to consciously think of, well, how do I do this? Maybe another good example is driving your car. If you've been driving for a couple years, you now have implicit memories of how to drive a car versus at the beginning when you were learning that skill, you had to remind yourself which side was the gas, which side was the clutch, which side was the brake. You had to remind yourself how soon or far away you had to be braking and all sorts of things. So other skills and procedures are implicit memories. You could think of them as muscle memories. You just know how to use a spoon. You've done it enough. It is a memory. It is a network in your brain of neurons to do that moving the spoon. But it's used so much you don't have to consciously think of it. It takes very little energy to run that memory process, essentially. So we don't often think of those as memories, but they are. They are memories. So the other thing is explicit memories. And this is what we're usually thinking of when we describe something being a memory. It's a conscious memory of facts, experiences. So if I say, what happened on your fifth birthday party, that would probably be an explicit memory. It's something that you have a conscious awareness of what happened. So most research does suggest that we don't really have many explicit memories from the time we are younger than two. So part of that is down to the brain still figuring out how to make memories. By the time that we could remember what happened when we were, say, 6 months old or 6 months old, we have kind of already overwritten those memories, it seems like, and maybe the brain just didn't hold on to them for long enough. So for 6 months old, it seems like we can measure about a day's worth of their memories. 9 months old, about a month of their memories. 10 to 11, 3 months, and then up to about 20 months, the last year. So again, this can be difficult because even up through a year and a half, you might not have enough communication, even like pointing to things to be able to really tell like what is a child actually recognizing and remembering. So it is tough to study these things, but it does seem like as our brain is getting better at processing memories, then we kind of get really rolling with creating memories. So most people's first memory is somewhere around like 4 and 5 years old. Again, there's a range. Some people will be a little earlier, some people will be a little later than that. A few more memory tricks and tips for you today. One is the serial position effect. This is our tendency to recall things at the beginning of, say, a lecture and at the end more easily than the things in the middle. So this is why I often try to take breaks during like an in-person class, because you're a lot more likely to remember things right after the break or right before you go to the break. So if you are in, say, a 3 hour course and you have no breaks, a lot of that middle 3 hours is really muddy. So it's not really clear in your brain. It's a lot easier to remember things right at the beginning and right at the end. So that's another good reason for taking breaks. Also, just cognitive energy wise, it's good to work with like a really cognitively intensive task for about 20 to 40 minutes and then take a break. If you're working 20 minutes, then your break can be fairly short, so 3 to 5 minutes. If you're working 40 minutes, take a break that's closer to 5 to 7, 8 minutes. All right, another thing is retrieval tasks and cues. So recall is like when you're doing an essay exam, you're trying to pull out the previously learned info, just recall it, versus recognition is where you have some kind of like, oh, I recognize that. So oftentimes on multiple choice tests, you will use recognition. Oh yeah, I remember this concept. I remember this answer. It's this one because I recognize it. You might also have recognition for like faces. So you say, oh, I recognize that person, right? So recall, pulling it out of thin air, basically. And then recognition is something is priming that memory. So encoding specificity is any information that's present at the time of writing that memory. And that can be an effective retrieval cue. So one interesting thing is if you study in the same place as you take your test, because of this encoding specificity, you tend to do a little bit better on the test if you take it in the same spot. So if you're taking a test in the classroom, stay in the same seat that you are in that classroom. if you're on your computer and you're taking the tests on the computer and you've done all your reading on that computer, you'll probably do just a little bit better from that. So with this, it also means that sometimes you might not recognize things outside of that context. So if you are talking about some of the same concepts in another class, it might take a minute before you go, "Oh, I do recognize this. I learned this in another class as well." Or if you ever saw, say, an elementary school or middle school teacher outside of the school setting, it might be kind of weird. It's like, "Do I know that person?" And then you realize, "Oh, that's Mr. Brown," or whatever it is, right? So that is another interesting thing with how we write memories to our brains. All right, a flashbulb memory is an interesting kind of memory. We can make flashbulb memories ourselves across our lifespan. Usually it's some kind of emotionally significant event. Oftentimes it's something problematic, traumatic, harmful to us, but it can also be something positive. So a flashbulb memory could be something really great that happens on your wedding day. A big study of flashbulb memories happened after 9/11. So maybe you weren't born yet when 9/11 happened, but a lot of people like me who were around remember exactly when they learned about what happened. They kind of have a lot of clear memories about that day, but I couldn't tell you what happened the day before that. Maybe a day or so after that, it kind of gets muddy again. There's some interference there. But yeah, I remember that someone came up to me and said the Pentagon's been bombed. Yeah, that was obviously a little bit incorrect, but I knew it was significant, and everybody was whispering about things that they had seen, and then that was like first period, or it might have been like a band practice pre-school. I don't remember exactly, but it was definitely the first thing I was in school that day. And basically, the rest of the day of school, I moved every classroom, but the teachers the whole time were basically just watching the news the whole day on TV. So I was learning a lot about what was going on and seeing the towers fall as well. So with this, any kind of emotionally significant memory could become a flashbulb memory, and depending on what it is, it might also be related to things like trauma and be easy to prime or trigger as well. And it does seem like it's an adaptive capacity that we can make these memories because it helps us make really detailed memories very quickly. And so that could be really helpful to protect you from things. So rather than getting chased by a saber-toothed tiger out of this cave 4 times before you figure out there's a saber-toothed tiger in that cave, hopefully you would make that memory that, oh, that cave is someplace to be avoided really quickly. Traumatic events are another example of memories that we tend to create a really vivid memory for. Oftentimes, it's a really stressful thing for us. It's something where you're having flight, fight, or freeze responses. And so that stress from the amygdala basically signals to the hippocampus that whatever's happening right now needs to be remembered. And so we create a pretty vivid memory of the events of the trauma, which can be very helpful in some cases or harmful if it creates things like lasting trauma after the fact, PTSD, these kinds of things. But essentially, it was evolved in us as a kind of survival capacity. So it's not always adaptive now. But that is why we have it. Even that being said, these memories, even though they are so vivid and clear, and they often have very heightened emotions involved in them, they still are prone to shifting slightly. So things like later emotions as you think back on the event, if you've worked through it or now you're even more worried about it, can change that original memory slightly. So slight distortions or errors you might not remember. As an example of a traumatic memory for me, sorry for anyone else who has had a really serious car accident or motorcycle accident. I was hit by a car on my motorcycle. And so an example of a distortion or a slight error, maybe I wouldn't remember the color of the vehicle, or maybe at one point I would have remembered the type, and later on I don't. Maybe I don't remember the person's face as well, these kinds of things. So those are some errors and distortions which can be important in court cases, right? A lot of weight is put on eyewitness testimony. If your court case, like let's say you sue a person because they hit you on your motorcycle or something like that for like the cost of things, medical care, for example, that might be relevant in say putting down your statement in a court case later on. If it's years after, or if finally there's, say, a criminal trial for some trauma that happened to you, it might be years later. And so that could be really relevant to what you say, because oftentimes more weight is put onto eyewitness testimony, but our memories aren't exactly like the little memory balls in Inside Out. It's not a nice, perfect little film strip that of exactly what happened. In reality, it's a little bit more flexible than that because we're using networks of neurons that can have things added and taken away from them. Like we'll still have that pretty vivid memory, but there might be some errors in there. Repression is another example of something that can happen to our memories. So we might repress a memory intentionally, like intentionally not thinking about that thing or thinking around that thing, trying to avoid it intentionally. But it can also happen just naturally. So our body realizes that this memory is threatening in some way, and so it represses it. It doesn't access that memory because the basically stress hormones and other neurons uh, send the message to not think about this memory. So with that being said, depending on how that happens, you may be able to access that memory again later through support, especially if it is from something threatening to you or some trauma. Definitely do that with, say, a licensed therapist. That would be the safest way to do that. But we can also do this or we can do this intentionally to forget something. So in that kind of case, again, if this is something that you wanted to forget for something that it might be harming you, probably wise to re-remember it with the help of a therapist. But in addition to that, if this has been long enough and not been accessed by other networks of neurons, that memory can just fade completely as well. All right, when we're talking about memory, we often think about the accuracy of a memory. So, are we getting facts right? Are we getting colors right? People's faces right? Who was there? And this does improve over childhood. So, preschoolers' memories are the most suggestible to misleading or incorrect information. And so, often, especially for prompting for events that are incorrect, can actually lead to distortions of the memories. So, asking leading questions, for example, might lead a young child to say one friend was there and the other friend wasn't, even though, let's say, if you prompt and say, hey, was friend B there? And it was actually friend A, they might now have a distorted memory saying, oh, yeah, it was friend B rather than friend A. So you can actually distort memories kind of like that. Again, these distortions are something realistic. Right? This is something that could happen. They've played with both those friends, maybe at the same place, but now in their mind, one person was there versus the other person. You might have this example too. If you have any memories where you were someplace with a bunch of friends, and maybe you remember one of your friends being there because they were always hanging out with you, but maybe they weren't actually there in this instance. It's another example of a distorted memory. So again, these kind of distortions, and we'll talk about it in a little bit, these are generally only realistic kinds of changes. So yeah, you're always hanging out with, let's say, these four friends, but this day, friend number four wasn't actually there. But when you think back on it now, maybe you do remember friend number four being there, even though that is an error. So thinking further about memory and how malleable it is very affected by suggestibility and misinformation. So misinformation from external sources can lead to the creation of false memories. That being said, a critical thing here is that these false memories have to be something that have been realistically possible in a person's lifespan, right? I have, had interactions with dogs, right? I have had dogs bark at me. I have had dogs like run at me, right? So it might make sense for me to create a false memory that maybe a scar that I have was actually from a dog biting me, right? That is realistic. It's similar to events that I've actually experienced in life. But that being said, I couldn't create a false memory that's so far out of the realm of my lived experience. You have to have memory networks to connect this to. So something super far out of my realm of existence is I've never been bitten by a dinosaur, right? So that kind of false memory wouldn't be possible for me to create. So I could create something that is a little more realistic. I think we have some examples later on. Nope, I've taken them out of the slideshow, but I'll give one example after the misinformation effect. One study found that when you asked participants a question about witnessing this car accident or a car accident in, say, a film, that depending on how you used the word or the kind of verb that you used, people estimated the car's speed to be different. So, on average, people who were asked how fast were the cars going when they contacted each other versus how fast were the cars going when they bumped each other, how fast were the cars going when they smashed into each other, those that were said told smashed estimated about 40 miles an hour versus contacted estimated about 30 miles an hour. So that could be a relevant thing in, say, a witness statement in front of a court or for an eyewitness statement at the side of the road after an accident or something like that. So this kind of misinformation can lead you to slightly alter your memory. It's a little bit malleable. Again, these are still within the realm of possibility, right? So 10 miles an hour, 15 miles an hour, 20 miles an hour even is not that dramatically different in like how we might observe it. And we probably don't see a lot of accidents at various speeds either. So with that, a good study was done to examine how false of a memory could you implant in a child. And so one of the settings, so they took a bunch of kids, I can't remember exactly how many, but essentially half of them, they gave them a more realistic to life false memory, and the other half they tried to give a very different from life false memory, but something that in some ways are similar to sexual abuse cases. So for the first group, they brought in the kid with their parent and they told the parent, "Oh, please remind the kid of this story." So the parent knew what was going on. They said, "Remind the kid of this story of what happened to them." And so the first story example was that the kid got lost in the store from the mom, that they were lost for a long time. They were very scared. They were crying. I think it was a mall. Like specifically, they got lost in a store in the mall. They were crying. The mom was trying to find them and they were lost for like half an hour. I can't remember the exact amount of time, but it was a pretty significant kind of story. And that they finally found them inside one of those racks of clothes that it's like all a circle. And so the kid was sitting inside there and was scared. So that was one false memory they tried to implant into this young child. The other group, same thing. The mom was told to tell them about a story of a time they went to the hospital and had an enema procedure. So that's a specific type of procedure that in some ways is similar to some sexual abuse cases with the type of body parts that are involved with it. So with that, they were trying to see, these again were kids who this had never happened to. The lost in the store example and the enema example, none of these kids had had that happen to them. So they tried to see, well, can these kids remember these things? And in both groups, some of the kids did, in reporting back a couple weeks later and even a month later, did report that they remembered it, but there were far, far more in the group that were the more realistic story. There were almost none, essentially, in the group that were told about the enema procedure that could remember it on their own versus the group that was told about getting lost in the store. They could remember that. They remembered being lost in the store, that they were scared. They talked about, they even expanded on it, said like things that they saw while they were hiding. And the reason why the researchers think this is because they already have memory networks. They've been in stores, they've probably been in malls, they may have even gotten lost at some point for a few moments and like been a little nervous and looking for the parent. So those kind of memories can be put together into a false memory that is realistic to the life of the child. Versus the enema example, since it was so outside of the norm, it wasn't possible to create a false memory like that. Then the main point in what this has to do with court cases is in court cases of something like and investigations of something like sexual abuse, it essentially tells us you should believe those kids. So while some specific details are suggestible and malleable, that they can't make false memories of things that are outside of their lived experience. So it's not a fun topic to talk about. It is an important topic to talk about, though. And if you want any resources for how to ask children about potential abuse, these slides in all these links are really helpful for that. The main point for this, though, is ask open-ended questions. Let the child do the talking. So lawyers know about this. Hopefully, police are know about this as well and are using these kinds of questions. So asking, What happened? How did it happen? Who was there? How does it make you feel? Like who, what, when, where questions rather than leading them any specific way. Because again, especially depending on the age of the kid, their language processing might not be as good. They might not be able to clearly articulate exactly what was going on. Right? So letting them lead the conversation versus inputting things yourself, one, lessens the likelihood that you will mold their memory in some specific way and gets you closer to what's actually going on. So, another couple open-ended questions. How does the other person react? Tell me about your relationship with this person. How do you see your future with this person? So these are really open questions. It lets the child take it and lead the conversation, gets you a lot more information about what's going on, and it's much better than questions like this. So these are the questions not to ask. So don't ask leading questions like, was this what happened? Did blah, blah, blah happen? Isn't it true that this? Wouldn't you agree? So any kind of declarative statement where you kind of put words in the child's mouth and say, is that what happened? Or is this right? Is that correct? That's not the way to go about this. One, you don't want to alter those memories. And two, you also want to actually get at the truth. If this is a situation of abuse, you want to make sure that you're protecting those children. So again, here are some of those resources in the slides. Feel free to click any of those links. Open-ended questions, letting the child lead the conversation and explain what was going on, what they understand of what happened, those kinds of things. Not close-ended questions. So again, there's those lists of resources. And oh, here is the, oh, here we go. 19 children were given those two specific examples of the enema versus the mall being lost. And other follow-up studies did the same thing. Dr. Pezdek was actually one of my professors, taught me stats, interestingly enough, versus actual cognitive psychology. Anyway, point is, she would be a good person to look up more research in this area with. All right, so that is a pretty heavy topic. If you need to take a break, feel free to pause the video, take a break, come back. We're going to move on to some things about forgetting and some study tips specifically based on how our memory works. But I know this is not a fun topic. That was not a fun topic to discuss. So if you need to take a break, definitely do that. But it is a very important thing to discuss about how our memory works. All right, a few things related to forgetting. One is encoding failures. If you're not paying attention to things, it's unlikely that you will encode the information. So an encoding failure basically means you didn't write that information into your memory. You didn't grab it with your working memory and put it into your long-term memory. Decay, memories do fade over time. Again, these are networks of neurons, and if you're not accessing that network, that memory can go away. So it's not exactly like the memory ball in Inside Out that fades to gray and disappears, but it's kind of similar to that. Essentially, your axons and dendrites have branches that are touching and connecting. If you're not using those connections, your neurons will literally reabsorb those branches or those dendrites to be more efficient because it's like, well, we don't need this, so it's not being used, so we're going to recycle this material. So another thing is inadequate retrieval cues. This can kind of combine with some of these other pieces if you don't have enough to connect to the new information. So if you remember back to the video of the 5 words that the person asked you to remember, we've got tree, highway, mirror, Saturn, and electrode. If one of those is a little disconnected from the other ones and you don't have a good connection to it, you might not be able to remember that one word. Right? So if you don't have good retrieval cues for the memory of some birthday party, you're probably not going to remember it as easy. That network might still be there. Eventually it'll fade. But if you don't have a connection, a way to trigger that memory, you might not be able to remember it. So now it's forgotten. Interference is another example. So this is when other memories get in the way. A really good example of this happened well, I probably have a lot of memories interfering with each other in my brain, but a couple clear examples are there were 2 summers where my parents took us, I was like 5 or 6 or something like that, took us to this camp spot. And it was in the mountains nearby our house, and we were at a creek. It was like a slightly different campsite each time, but it was the same campground. So this was 2 different years at this campground, but I remember it as one camping trip. All of it is together. It was one trip, even though it was a year apart, all sorts of different things. So because those memories interfere with each other, the networks of neurons are so intertwined that the other memory of one year gets in the way of the other one. A similar example that kind of made my parents sad recently. We went on a big family reunion and they were talking about things that they enjoyed doing with the family. And I remembered one big long road trip across the country, visiting like historical sites. And I mentioned, yeah, then we went to this place, and then we went to this place, then we went to like the Liberty Bell. And they're like, oh, that was a totally different trip. That was like 2 summers later that we went on another cross country trip to all these different places. But again, in my mind, both of these times are the same exact trip. So they're interfering with each other. So I have memories of places we visited along the route, family members we visited that were in totally different years from one another. So interference. So kind of funny. Made my parents sad, but I mean, I do have the memories, mom and dad. They're mixed up. They probably have mixed up memories too, that they don't realize. So with this, if you try not to remember something, you will and deliberately try to like think around it, you can then repress that memory and forget it. So again, depending on what it is, that may be easier, that may be harder. Yeah. So those are some of the ways we forget. Another thing with encoding failure is the brain has only a limited amount of energy. So this is our brain's forgetting curve. For any new information, about 20 minutes later, we have forgot about 50% of it. So this lecture has been, I'm not sure how long at this point. You've probably forgotten quite a bit of it already. And then after 24 hours, we forget about 70% of the material. So after a day, you're only remembering about 30% of the material you learned. That being said, if you attend to it, if you work with it, if you use some of these elaboration strategies that we've talked about, if you've used mnemonics, this curve is not as steep, right? So this is for things that you're a little bit more passive about. They might not be getting encoded. But that being said, one really easy way to fight this forgetting curve is by reviewing material. So especially in a school context, this is one reason I ask students to read the book before they attend lecture. Because first you learn that in the book and you forget a whole bunch of it. But then you come to lecture or you listen to lecture and you remember a lot more of it. That forgetting curve is way less steep. Hopefully in both of those processes you are taking notes and then your curve is not as steep anyway once you've been taking notes. So you take notes, less steep. You take notes in class, less steep. Then you review your notes a few days later, much less steep. And then you study again before the exam. You're going to remember a lot of that material for a long time. Very flat forgetting curve in that kind of case. So this is one really important reason to do the things like taking notes on your reading, taking notes in class, reviewing your notes later on, read before you come to class, ask questions, elaborate on the material, put meaningful examples into your notes so that you don't forget things. Because if you are forgetting them, you're not going to be able to connect them with other things in the future, with other courses, and that is a problem with our brains, especially when we're trying to pack so much in within, say, a quarter in the term. So amnesia is another example of forgetting, and this is anterograde amnesia is the inability to store new information and events versus retrograde amnesia is the inability to retrieve past information and events. So someone with retrograde amnesia may be able to make new memories, but they can't remember, say, any of their birthdays up to this point. And so those can be caused by a lot of different things, whether it be stroke, injury, illness, all sorts of things, infections, which is that the same as illness? But anyway, amnesia can be caused by a variety of different things. So also these are some memory errors that can happen. We've talked about some of them. We've talked about suggestibility, misattribution. Your source of the memory is a little bit confused. We've talked a little bit about that. But yeah, here is a whole list of other ways that your memory can make errors. Maybe some of these look familiar to you. But with this, I have some study tips for you. So one, we just mentioned, review your notes. Check for errors, revise your notes. One thing I recommend for students is as they go before taking an exam, rewrite all your notes up to that exam on one single page. So, and I don't mean like write them all very, very tiny. I mean, take the most important things or the things you think you're going to forget, or both, the most important things and the things that you're having a hard time remembering. Rewrite those notes more briefly on one page. And so you fill up multiple chapters of notes on one single page. In our class, depending on the which class you're in, you may be able to use those notes on an exam. In some of your classes, you can use those notes. It just really depends. So so do that, review your notes, rewrite your notes. It's a really fantastic study tool because what you'll find is even if you're allowed to use that page of notes, you almost will never have to because you will have remembered all of that material so well now. So another thing to do is arrange it into memorable structures. So whether you use hierarchies, like make an outline saying like, this is about behaviorism. Behaviorism is built of operant conditioning and classical conditioning, and also behaviorists only look at behaviors or something like that. Or you do like the bubble method, like the network bubble method. You can write on a big whiteboard, for example, like one specific thing. So you can say, behaviorism. And what do I know about that? Well, I know it's about learning. So put a bubble of learning over here and say operant conditioning over here. And that's connected to learning. Classical conditioning is connected to behaviorism and learning, and kind of like network things. Some of my friends really love doing that. And some of them are very, very smart. That method doesn't really work for me, but it seems to work really well for them as we studied for exams together in grad school. So I definitely recommend it, even though that specific one doesn't work for me. Another thing is analogies. Make analogies, make stories to familiar things to you from your notes. So if there's some example, some concept that we learn about, especially in psychology, it's very much easier to do this in psychology than some other fields. Like say geology, you might be able to connect it to like the time you saw this kind of like rock. But again, I haven't taken too many geology classes, so maybe I would have better ideas for connecting geology to real life had I been in more than say like, I think I might have only taken one in undergrad in geology. Taken a couple astronomy classes though. Not the point. The point is a couple other memory study tips are give undivided attention to what you are doing. If you know you have people trying to talk to you a lot, you're going to get a bunch of texts, a bunch of emails, put those things on silent. Focus for your 20 or 40-minute study session. Then maybe during your break, you can respond to some of those. Then come back and study again. If you are distracted by music with lyrics, don't listen to music with lyrics. A lot of students will try to listen to, say, a Netflix show in the background. Don't do that. Even if it's a show you've seen so many times before and you think, well, I can just have it on as background noise. No, there's sometimes you are going to be pulled away and attend to that and move your attention away from what you need to be focusing on with your schoolwork. If you're trying to do some hard problem for work or something like that, that's another thing that can pull your attention away. So, for example, I might have Gilmore Girls on in the background and can usually ignore it. Not a big deal, but there's sometimes you might just get pulled away by Rory and Jess and just have to watch for a couple minutes. But in doing that, you've pulled your attention away from your schoolwork to the romantic drama and then back over here. So, as fun as that is, it still makes it harder for you to remember those things. Another big thing, make associations. Make connections to things in your own life, make connections to people in your own life, situations, make connections to other things you've learned. So in our class, we've gone over things like biology, learning, and memory. All of these things are really closely connected. So learning is partially a memory process, right? Using imagery. We've talked about a couple examples of using imagery. Use chunking, put things together. So as an example, two of the words in our mnemonic activity were paper and sand. You could chunk those together as a piece of sandpaper and use imagery to imagine a sandpaper. So encode early and often. So review or do your reading, come to class, review your notes. That's essentially what that means. Another couple things is talk to yourself or others about the things that you've learned. Ask questions of yourself. Essay questions are the best. This is actually something that ChatGPT can be really good at. You can give it, say, a chapter that you read and say, hey, give me some essay questions about these topics, and then answer those. Right? So that would be a really great study tool, pretty good use of that kind of tool as well, that kind of AI tool. Rest, eat well, like take care of your body, exercise, these kinds of things. if you take breaks, you will get more primacy and recency effects as well. So study for 20 minutes to 40 minutes, depending on how much your brain can handle, and then take a break. Do something very different on the break. So a good break, right now I'm sitting in front of my computer screens. A bad break for me would be stopping this work and then opening up a YouTube video. That's not a great break. A good break would be something like going and getting my kids dinner. Very different than what I'm doing right now, and that would be a good break. So use retrieval cues. Context clues can help. So if you're always studying in the same place, you take the test in the same place, it can help. And try to keep comfortable and calm as you do something like an exam. So this is a list from your book, from the default slides from your book. And I think we hit most of these, even if we didn't necessarily use the same words. So yeah, use these tools, use these strategies, and you will do well in all of your classes, not only this class. Understanding how your memory works can really help you to leverage the memory capacities that you have. If you want to work on your memory, there's a ton of ways to do that by exercising it, essentially, learning new things. We've talked about a lot of things that can improve your cognitive performance. Essentially, all of those improve your memory as well. So if you want a review, especially of some of these topics and some specific study tips, this YouTube video is pretty good on as a review, but study tips, we did kind of cover everything in it. But if you want a shorter video than this entire lecture, you could look at that. But that is our chapter on memory. Hopefully you remember a lot of what we covered.